So this is the last panel on address family translation and NATs and CGN. And being the last one and kind of having a sedate last few days, or perhaps hungover last few days, perhaps we can have some grandiose statements and outrageous claims about NATs. So I'll start off. As you've heard recently, NATs are the solution to all problems. If you're going through a divorce, if you've had a recent car accident, you can get a CGN supplied by your vendor and it will solve the problem. But let's get into the real problems. And first, it's that allocation of IPv4 addresses is running out. I think everybody's seen this slide at least 50,000 times. But we all know that there's also challenges to v6 deployment. We all waited too long. Me as a vendor, also doing specs and running working groups at the IETF, their specs aren't done, code isn't done, boxes aren't built, boards aren't deployed. And also, there's been a wide range of existing transition mechanisms. In the old days, 15 years ago, or whatever you want to say, when v6 first was being developed, it was let a million flowers bloom, and they all bloomed, and then reproduced, and then some. And so there's lots of things out there, and unfortunately, most were tuned for specific deployment scenarios, which made it difficult. And then there was various other ugly solutions that were brought out as well. So couple first statements by an operator, a good friend of mine, basically claiming that v4 only hosts and devices are going to remain in the network for up to 2 decades from today. So we're looking at a very, very long time for a complete transition from v4 to v6. 2 decades might not be long enough. And Leslie made a claim at the last IETF that the critical failing of v6 was that it wasn't backwards compatible. So what's to be done about this? Well, the v6 upgrade, as we all know, is a pretty expensive undertaking, both from CapEx and OpEx, in particular because perhaps devices have been out there to be able to forward v6 packets for quite a long time. But the back-end processes and, quote, the ecosystem of tools necessary to actually deploy networks really aren't available today. So trying to deploy a service without all the tools, in particular being able to bill for it if you're a service provider, is very challenging. So also, standards just aren't done. It's very, very difficult to bring up an IP subscriber that's v6 only. Today's network, we just had a talk. You can use PPP over v6. Nothing's wrong with PPP, but it's kind of using yesterday's technology to solve tomorrow's problems, which can be problematic for some. Other challenges, of course, include that nobody can stop doing business. We need to keep rolling out new subscribers, and that means that maybe we need to do something with v4. And last, there's a whole new marketplace emerging on sensor networks. It's been worked on for, say, 15 or 20 years, so it's not particularly new to us or new for people to talk about. But what is interesting is that these devices are trying to be moved to work over IP versus proprietary protocols. That's a good thing. And what's interesting is that those standards and specs are being done with v6 only. So first grandiose statement is that, let's say, today's internet looks like a lot of public v4. But tomorrow's internet, I think, is going to have 3 address families that need to be managed. Global v4, public v4, and private v4, and then IPv6. And all 3 need to be managed, understood, and they are going to be deployed. So there's other grandiose claims that I can make, that in fact there is no killer app for IPv6, and that's what's caused some challenges to deploy it. But in fact, today's killer app for IPv6, and certainly for the next couple of years, is really the public v4 address. Do subscribers have to have global or public v4 addresses? Can they live with private addresses? What can you reach if you're v6 enabled or v6 only? These are serious challenges. So again, the public v4 address may be the killer app and may be the business driver to deploy v6. We can talk about that a bit more. So really, taking a look at some timelines out now for the next 10 years or so, there's a few different strategies that one can employ to deal with this transition. One is preserve v4 as long as possible. Use private addresses, attempt to reclaim public addresses from equipment, subscribers, maybe that aren't revenue generating, and move those over to v6 first and leave the subscriber alone. That could be called a coexistence strategy. And then last, which is very difficult, is to try to deploy services over v6, whether it's voice, video, or the typical quad play stuff that a service provider is doing. Those devices and specifications are not done. So let's talk about what can be done now through the next few years. And really, that's a whole lot of attempting to preserve onto v4 that's available today. Now, there's a number of different technologies that go into these three categories, whether it's translators, which we've heard a lot about in the last few days. There's BGP prefix validation, which Randy talked about, but that mechanism to secure and certify that a v4 announcement is valid can turn into a v4 address trading market, because that validation and certificate is now a title that can turn into a lease. And so these things become interesting to think about what is the value of a global v4 address and what is the value of an announcement, as to get access to these global v4 addresses that are currently allocated but not being routed upon means deaggregation. So again, there's more things to think about of what's necessary to actually find the value of these v4 addresses. Across the coexistence infrastructure, we have some panelists who want to talk about DualStack or tunnels encapsulation or address family translators and gateways, and there's a whole plethora of things here brought to you by perhaps your favorite vendor that may end up being confusing, because again, a million flowers blooming and then reproducing again may not be the best strategy to attempt to go forward. So with respect to address family translation, we've known about it for a while. NATs in general and NAT-PT has been around for a long time, and it's caused some issues, right? There's a lot of state that needs to be held. Just taking a look at the DNS stuff is enough to blow somebody's mind on what a NAT-PT device actually does. And so we've been talking for the last, let's say, year or so, I guess, about carrier-grade NATs. And what's interesting about carrier-grade NATs is that really it's a TLA for all catch-all functionality that seems to be loathed by a number of people. It talks about tunnels and encapsulations because it's a tunnel concentrator. It translates IPv4 to IPv6 and back again. You can do v4 public to v4 private and back again. And you can basically translate, address foo bar to address bar foo if that's what's necessary with these particular devices. So it's everything, but we just decided to call it CGN for lack of a better term. Moving forward and taking a look at address family translation, there are real use cases for which we need to think about and discuss whether or not they're going to be persistent and pervasive throughout the network, just because new v6 technology, and there's some examples up here from Windows 7 to LTE for mobility, et cetera, needs to get back to the v4 world. And how is this going to be accomplished? So there's various different flavors that we're going to talk about. We've got different panelists to talk about these different bits of technology. And as you're reading these slides while I'm talking, right, we know that we have NAT 4.4 or NAT 4.4.4, depending on the levels of hierarchy, where you're going between private v4 addressing to public v4 addressing. And we'll talk about some of the issues trying to deploy that. There's other variants of this where you can have tunnels that go to NATs as well. And it'll be discussed which is an interesting encapsulation and why, and what are the pitfalls of this technology. And so we'll hear a bit about that. DualStack Lite is one specific design here. We have an implementer and a deployer of DualStack Lite, and the inventor as well. And so this, again, is how to tunnel back to a tunnel concentrator. We could call it a CGN, and then do address family translation or NAT on that particular concentrator. Last, there's a bit of technology that we're not going to talk about today, but nonetheless is out there, which needs to at least be mentioned, which is being able to do these types of functions across the core of a network. So right now we've got 6PE and able to do this with VPNs, but the problem is that 6PE doesn't handle the global table well. You don't want to have to redistribute the global internet tables back into your VPN tables. That would explode the memory on the line card. So there's this technology called SoftWire's Mesh. And what this does is it introduces the concept of an address family border router, in which you can speak BGP to a v6 island on one side and have it traverse a core of say a v4 core or a core of another address family and have it pop out the other side, and have a notion of islands that can deal with a global table. And so this technology is available for cores of the network. So the reality of infrastructure and connectivity is that these devices that are termed CGNs really do a large number of functions. Again, private to public addressing, v6 to v4, terminate tunnels and then do translation, or just terminate tunnels, so that way you can connect hosts to network nodes that can support that address family. And the question really becomes, are these things going to last forever? What interesting operational overhead do they introduce? And then what other problems can they solve? So on the panel, We have Suzanne, an implementer. We have Alicia, a researcher, Alon from Comcast, and Chris Chase from AT&T. And so what we're going to do is we're going to hear a few of their opinions, grandiose claims, and other statements. Alicia will go first, then Suzanne, then Alon, then Chris. And then we'll open up to the floor to any questions or comments that folks might have back in reply and have an interesting conversation. So, Alicia, I turn it over to you. Let me get this going for you. There you go.
Thank you. Well, people say that the best is saved for last, and therefore I'm definitely not the best. But I'm willing to come here, give you my 2 cents. I guess the reason that I actually got picked by Dave probably is because of this. There's a shameless self-advertisement. Back how many years ago when the V4 net first started, I had a particular view on the net, thinking that whether it's good or bad. After many, many years, looking back at the reality, I wrote this short article on the retrospective view of the network address translation. Whoever interested, you can go there, take a look. Being one of those academic people, what we do is we publish, right? But to save your time, I can just summarize what's in that paper. Essentially, it's one sentence. That is, people's fundamental goal is to connect it to the internet by whatever the means. And more importantly, they take the most pragmatic way. At the days when IPv4 net first started up, there was a huge debate. I think many people here probably remember that regarding whether net is evil or not evil. Where is end-to-end principle? But despite all this respect to the end-to-end principle, nevertheless, net got deployed because that's the most pragmatic way to get one connected, and it's the most effective way to get around the network address shortage problem. So what I come up out of that, looking back effort, is that I think the easiest and cheapest way wins. Now, so coming to today, we have V4 still there. We have V6, well, hopefully coming up soon. And given that it's one level of indirection introduced by NET, solved the big problem in the past 10 years. So NET now will come to rescue us for this V4, V6 transition. But this time the picture is a bit more complicated, like Dave already mentioned. I like that picture he had, with the current NET on the left is a simple one. In the backbone is still public V4, and the NETs more or less around the edges. I wish I had shown that picture. But today, when you want to do the translation, the picture gets more complicated because there's a NET 4, and there's 4 to 6, and spec 6 to 4, and there's tunneling. So it's not just the clients and the servers. They may run different versions, 4 to 6, 6 to 4, whatever that is, but also the networks in the middle. That could also be different from either the client side or otherwise from the server side. And therefore, the result, so when you use the NET to bridge the V4, V6, not only you have the old problems of translation, 4 to 4, you have the 4 to 6, 6 to 4, and not just the NET. Now we got the combination of tunnels as well. If you look at the NET, what that is, we computer science people always like to summarize things and turn that into some kind of, well, I cannot say theories, but at least the rule of thumb. One of them says that there's one level of indirection solves all the problems in computer science, and the NET is one of those. Tunnel, in some view, is also just another level of indirection. So what I summarized here is that one level of indirection solves all the problems. That's why we got by with network address shortage for so many years until today. And now we have NAT, we have tunnels, so we have two levels of interaction that are going to solve even more problems. Is that good? Yeah, I think so. So I went on to Google to see whether I'd be the inventor for the new phrase of two levels of interaction solves even more problems. And you know what Google turned out as the answer to us? Here it is. You can solve every problem with another level of interaction, except for the problems of too many layers, too many levels of interaction. I just hope that people will keep that in mind. So to get my quick talk finished, what may be ahead of us? Of course, we hope that we're going to see increased deployment of IPv6 at the servers, at the clients, and at the networks. And with that, we're going to see NATs, lots of NATs, and lots of tunnels. What I see now is that people pay lots of attention to see how we can do the NAT in a perfect way in order to handle all the gazillions different specific cases, and how we're going to massage the tunnels into that very interesting picture, making the whole thing even more, I hate to use the word complicated, so I use the word challenging. What I haven't seen talked much about is really the network operations. And I worry about the network connectivity debugging challenges. But what I see, I hate to be, well, I know you're just off the ISG, so I'm okay to sing this without people just punching me now. What I'm saying at this moment, I'm off, I start to. At the moment is that people are really trying to look at the perfect netting mechanisms between V4 and V6. So what I put down here is that, okay, if we don't think the forthcoming network operations challenge is challenging enough, so what we are doing here is want to make it more challenging by creating multiple alternative ways of this translation between V4 and V6. I tried very, very hard to catch up behave mailing list to figure out exactly how many ways so I can count it and put the number here. I failed because there's so many message exchanges. But that's what my worry is. You know, for us academics, we don't build boxes, we don't run the networks, but at least we watch. We watch what has happened, and we try to learn something from it. I think complexity, I think V6 is coming, this is for sure. And NAT, tunneling are necessary evils for us to get through this transition stage. But there's no point to optimize, to make it perfect by creating this, you know, I don't know, n ways of netting between V4 and V6. I think that's going to add more complexity and get more, whatever the challenges we're going to face in the coming years. That's the end. Thank you.
Thanks, Alicia. There you go, Suzanne.
Good morning, everybody. The caffeine seems to have hit. Yeah, I've only really got a few slides, so there'll be more room for people to line up at the microphones and have opinions. I'm Suzanne Wolf with ISE, and after getting up here to talk about DNSSEC yesterday, I decided I'd do something simple and non-controversial and get up here today and talk about CGN and V4, V6 transition. So first, with just what ISE is doing in this space. We have funding from Comcast to develop an open source of implementation of CGN technology. The particular form, given Dave's taxonomy, the particular form we're working with is DualStack Lite, but really what we're doing is prototyping and then feeding back into both experience and specification, because frankly we expect all of this. It's very much a moving target at this point. There's a great deal we don't know until we get code out there about how these things work and how different things interact. So the initial deliverable is a prototype of DS Lite as it has evolved so far and will undoubtedly continue to evolve with our customer. We're doing all the stuff you do with a prototype. We baseline the functionality, we're baselining how does it perform. We started in userland because that looked easier at the time. There will be a kernel version on on commodity Linux and commodity hardware. The kernel version will be harder to build, should perform better, should be easier to instrument in some ways. But there's a great deal that's still unknown about how to quantify and characterize what we're doing and how it's going to act. And the heart of the work, just as given the technical descriptions, the heart of the work turns out is just in managing the mappings between v4 ports and v6 and managing crossing packets across those mappings and building and tearing down tunnels and getting the right level of dynamism in all the moving parts without breaking things. We're not committed to a particular architecture, and we started with DualStack Lite just because that was the starting place that we worked out with the customer. We do have a philosophical and operational preference for small, cheap devices as close to the edge as reasonably possible. Given that we've got some prototype code, we're working, now that we have most of the functionality kind of off the slab, we're working on making it more useful. Better logging and instrumentation, full details on all of the moving parts. We need a better configuration interface for different use cases and different ways of using these devices. We do need to look at performance. We need to know realistically how many users you can support on this kind of configuration of commodity gear and fairly generic networking code. And among particular things that are kind of close to our hearts, we are particularly looking at integrating other CGN variants that have the same preference we do for control kind of closer to the edge of the network. We're seeing all the things, and we're seeing all the things you anticipate with making this work. This stuff really is difficult to debug and configure and document, and the key challenge to make it useful is to be realistic. Yeah, it would be simpler not to do NAT in v6 land. It's just not going to be pretty no matter what we do. So when Dave invited us to consider being controversial, I figured that I'd take a minute to talk about what the project means to ISE. We're a not-for-profit company. We're expected to act in the public interest. This doesn't mean we're not allowed to do things for money. We have payroll to meet. We have mouths to feed. But we do have to also keep in mind the broader impacts of what we're doing are going to be. So to cut right to the chase, everybody awake? We know some people think CGN is intrinsically evil. We don't think so. We believe that the underlying idea is sound, that IPv6 deployment will be aided and may not ever happen at all without moving the solution close to the people that have the problem. Content providers, it's not clear they need IPv6. They have IP addresses. End users don't need IPv6 for the reasons we've already talked about. They have IP addresses. It's access providers that are running out of IP addresses, and they're the ones with the problem, and they need to be the ones with the solution. So given the reality of the situation, it's basic to our philosophy that freely available open source lets everybody look at the ideas and the code. Take what's useful. Take what you like. It includes whatever people want to do to make the model and the code useful in their networks for their particular situations, their particular use cases. And we expect change. We expect things to be tried, and given, even with the downside risk of let a million flowers bloom, the alternative risks are probably more serious. We need to know what works, and the only way we're going to know is if we try. So let's make it possible and see what people do. I have to admit, I'm some kind of NANOG Pollyanna up here. I have the same optimism about this that I have about DNSSEC, which is that once we've gotten some experience and refined the ideas and gotten some code out in the world, we're going to be enabling some things that weren't possible before, and some of them are going to be good. We just don't know yet. I do disagree with the contention that it will leave us worse off, especially if we think about what we're doing as we do it. So we'll be showing more. You'll be seeing more from us. We'll be sharing some early prototype code with a few friends and family soon. You know, see us if you're interested in looking under the hood and seeing what's really going on in the code. We are looking at doing a CGN Forum for other potential partners who might want to work with us on future development. That's modeled after what we do with Bind and DHCP, our other well-known products, where it's a way for partners to interact with us and work and be part of evolving the technology, deciding what happens, what comes next. We are going to continue to work on the prototype and move that towards more mature code. So see us if you want to see real code. Thanks.
Thanks, Suzanne.
Hi. Good morning. I'm Alain Jean from Comcast. First thing I would like to do is to make a reality check, actually two reality checks. Well, the first one is, you all know that we are going to run out of v4 addresses. It's nothing new. But we also know that everything that was allocated so far is still going to work the day there will be no more v4 addresses. So it's not like there's no more oil and the cars are not running the next morning. As everything that worked still worked. And this is about the new stuff, things that is deployed after there is no more v4 addresses. The first comment is that it seems to be somewhat tight with the economy. I've made some statistics, and I've been tracking some of the projections as when we are going to run out. And I've been tracking that since July last year, and it seems that we are constantly 2.2 years away. That we have a day-by-day shift. Which means to me that as soon as the economy will pick up or something else will happen, we may just run out in, well, much less time than 2.2 years. So this is something that is very, very real. Now, reality check number two is we have customers who have tons of devices in their home. This is not just about the computers running Windows, Vista, or Windows XP, or Macintosh. This is about those devices. This is a Skype phone. This is about a TV, like those large TV who have an IP interface. It's about a VCR who have the same thing, phone cameras, the point-and-shoot cameras who have a Wi-Fi interface to push their pictures on the web. We have now a lot of those devices who pop up on the network at our customers. Most, if not all of those devices have an IPv4 stack. This phone has an IPv4 stack, no IPv6, never going to get upgraded to v6. Maybe the same phone that we buy 5 years from now will have IPv6. Maybe if we are lucky in 2 or 3 years from now it will have IPv6. But this phone here is not going to go away. And maybe this one is going to be disposed of in 2 years because the battery will be dead. But there are still millions and millions of other devices that will have a lifetime that will be longer than that, but are still going to be in homes network way after there will be no more IPv4 addresses. And that's a real challenge. The other real challenge is on the other side of the internet is all the content on the web. Sure, you have now Google, and we have heard about Netflix and a couple others who are moving to v6. But even if 80% of the most viewed content was to move to IPv6 in the next couple of years, there will still be a lot of places on the internet that are going to take more time. And we actually do care a lot about all those places because the internet is not just the mostly watched content. It's all about all those community of users who have interesting things to share together that may not be interested to the wider audience, but folks get a lot of value from this long tail content. And until essentially everything or most everything is moved to v6, the notion of an IPv6 only service is not very realistic. And so this is a case where we have a misalignment of cost and benefits. Even if us as an operator were to say we do absolutely everything and we give you an IPv6 pipe and just go ride it, this is not enough. We will have to wait essentially for the entire industry to move to v6, for entire users in the home to move to v6 for this to be any useful. So that's not a realistic situation. So, taking this into account, the approach that we are recommending is to say it's a two-pronged approach. A, embrace v6. Move as many services and devices to v6 as we can. First thing is that it will lower our dependency on IPv4 address, and it moves some traffic there, and that's where we want to go. That's the happy place where we want to go. But at the same time, we need to be mindful that we cannot live the IPv4 world. It's not like we burn the bridge and forget about v4. We still need to offer some v4 service to new customers. It's not about existing customers, but new customers. Provide the v4 service without providing a dedicated IP address per customer. It's really about sharing those IP addresses. It's not going to be the same as your old IPv4 internet. Okay, we move on. The future is v6. But we still need to maintain this connection to the IPv4 world. And the technology for this, we believe, is really combining those NAT and tunnels and this DualStack-like technology. The key point to keep in mind is we will have v4 and v6 traffic. So v4 traffic essentially is going to go through those tunnels and those NAT. v6 traffic goes straight to the internet. So that's great, because as much traffic we can get off to the v6 network is as much traffic that will not go through the NAT. So I used to say a byte that goes over v6 is a byte that will not go over the NAT. So the more traffic we get there, the less pressure we have on our NAT infrastructure that we have to put in place. So we can think about essentially a cap and grow strategy. We have to put those NAT in place, category NATs of any flavor you want, to keep the service running. But the more we move toward v6, the less money we will have to put on this NAT infrastructure. And that also illustrates another point is, if we can make sure that we align somehow the cost of deploying a NAT and the cost of doing v6, and make sure that those two costs are not at odds, then they can leverage each other, and we don't have to do twice the investment. Now, if we were to do a separate set of investment for NAT and a completely separate of investment for v6, that may just delay things and make things twice as expensive. That's not necessarily the best thing. The one thing that we don't like is this picture. The mega CGN, the mother of all CGN, where all the traffic goes through a CGN. And to make a controversial statement, this would be more like a PSTN service, and this is not exactly what in this community we like. The number of dollar signs may reflect the total price of the box. This is expensive, but not only expensive, what we are really, really worried about is the failure domain. If this box was to go down, then we may have millions of subscribers that will be impacted. So our vendor usually tells us, buy 2 boxes. Well, we know that if one box goes down, then 2 boxes can go down also at the same time. So that's not exactly a good solution.
Buy 3.
Well, buy 3, buy 4. It becomes a little bit too expensive at some point. You know, it's like Lisha was saying, maybe too many levels of NAT is too much, but too many levels of redundancy is too much. And some of my friends who count like 1, 2, several, many, and too many on my 5 fingers, and we quickly go to the too many. So instead of this big giant mega box, we would rather like a much more distributed system. And this technology is based on tunnels, and we have a DHCP option to create a tunnel endpoint, to discover the tunnel endpoint, meaning that we can actually say this group of users is going to be configured with DHCP to go and use that CGN. Another group of users is going to be configured to use another CGN. If one of those groups gets too big, we can split the group and separate the traffic toward different CGN, and essentially soft cable your CGN infrastructure. Same way you can start with something that's somewhat centralized, and if you have more of those boxes, you can start to push them closer to the edges. And send them essentially to as many boxes as you can. So this is an horizontally scaled solution. This is something we have seen in the server world a couple of years ago, where initially people were using mainframes, vertically scaled solutions, and moved to just rack and stack solutions of commodity-based hardware and dramatically reduce the cost. Well, we think we can do the same here. So as a conclusion, this is not that we like NAT. It would be much better without it. It's just that we have no choice. We need to care about growth, and we need to care about maintaining some form of IPv4 service without having enough addresses to give one to each customer. So there's no other solution than sharing. And we have to learn how to share this in a system that will be at a reasonable cost, because nobody is going to make any money running an infrastructure like this. It's going to be expensive, so we have to make sure that the cost remain low as possible. And while offering to the users some level of control on this infrastructure. We heard loud and clear in the recent months that users wanted to have some level of control with A+P technology or port forwarding technologies, making sure that they can control their own port, they have their own presence on the web that is under their own control. Have I said control long enough? So we are going to do that. It makes a lot of sense, and it seems to be a critical thing to do. So we think we can make this work. We have a demo that is running on the top floor here, on the 33rd floor. If you are interested, you can see it right after this panel. It's going to be up and running for at least, I think, 30 minutes after this panel. And I think I'm done. Thank you.
Thanks a lot. Chris?
I only have a few slides. I wanted to talk about a NAT4.4 scenario for doing CGN and what are motivations for doing, say, NAT4.4 versus the DualStack Lite. Of course, we have the need to mitigate our IPv4 exhaust. We have services that depend on IPv4 today in our triple play services, and they will not be IPv6 ready anytime soon. We need to provide, during our transition to V6, we have to provide the ability for our users to get to the V4 internet, if you want to call it the legacy internet when you're talking about V6. And we need to be able to put the NAT somewhere in the network. We would like to put it somewhere that would mitigate any impacts on the existing triple play services that we have. So in this figure, this shows the carrier grade NAT at the edge of a metro network, the aggregation network. The, for example, IPTV services in this case would be on the inside, the private side of that CGN. We have other services, the voice over IP services, and our operations and management systems that would be on the public side of the CGN, but we have a desire to not NAT those services. Whereas the internet services would need to go through this second NAT that's in the middle of the network at the edge of our metro. And it would need to be able to be carried across our backbone. In the case of the blue non-NATed traffic, that means that we're going to have to be able to route the IP address space across our backbone and be able to handle that. I did want to say that AT&T's IPTV service, or a triple play service, is called UVerse, as opposed to our legacy ADSL broadband service. And in that service, the CPE is managed by AT&T. But we are not currently looking at the dual stack where we would get that component there. In this solution, in the NAT4.4 solution, we do not have to make any changes to the CPE. It would continue to do its current NAT4.4. Just wanted to say a few more things about the NAT bypass that we would need to do with some kind of policy routes. Operations and maintenance, the way we manage the managed CPE today is done over our national backbone. It's not deployed regionally into the individual metros. And so that traffic would not be able to be NATed since the connections are initiated from the management systems. We have a desire to not NAT our CVoIP traffic. So the traffic, the registration traffic that goes to the session border controller that resides on our national backbone, that would not be NATed. If there's any media release to a client that's within our network, we would not want to NAT that either. So any media release between two clients that reside on our own network, That would not be NATed. That would be using maybe private to private or private to public IPv4 addresses. But if it had to go outside our backbone, then if we do not want to NAT it, then we're going to need to anchor the media at the session border controller. So only the internet services components would be NATed in this case. The hope would be after we transition our services like our operations and maintenance and our CVoIP services to V6, that within we can remove routing the private address space from the backbone. And as I mentioned before, the IPTV services would be within the NAT in the metro network. Right now, we do not see any need to transition that to V6, and it does not need to be NATed. We have hundreds of national TV channels that are multicast across the national network. However, that doesn't use customer address space, the residential gateway address space, and so it doesn't need to be NATed. I did want to say a few comments about managing this CGN. One thing is, if we do have to route a private space across our national backbone, then we have to manage that space like any other space inside our network. We'll have to manage it through the systems that track the address space. We have to allocate it just like we would any other address space. We already have some private IP routing in our national backbone, and so it would have to be managed along with this space. Also, we have the issues of course, the CGN was going to break. Certain services, dynamic DNS would not work. In this case, we hope to mitigate some of that, for example, by providing a static port forwarding configuration that could be done on the CGN in the middle of the network, so that, for example, you could do redirection on a known port on the external side of the CGN. And we also have a need to log the NAT state. We're concerned, we've been told that for legal reasons that we need to know how to trace back traffic to a particular user, and with the CGN in the way, we can't do that. And so we're going to have to keep a NAT state history, and there are concerns about how we would scale that up and what kind of history we're going to have to keep for those transactions. This slide shows a sample we did in the network back in September of the distribution of NAT states. Back in September, we sampled over 700,000 residential gateways and what their current number of NAT sessions are in the network. The x-axis here is a logarithmic axis, and what it is we binned up, we counted, for example, how many users had 0 to 4 NAT sessions, how many had 6 to 10 NAT sessions, and that's what this histogram shows. And it has a very, very broad distribution. There's a maximum of 1,024 NAT sessions in our current managed CPE, and so it stops right there at the maximum, and there's actually another mode at that maximum, which are our engineers identified as BitTorrent users. We have very widespread of users here in this distribution. We did the same analysis in December. Over 1 million RGs were sampled for their NAT states. Similar statistics. The average here was 57 NAT sessions per subscriber over all the subscribers, whether they were active or not. And when we did it again in December, it was 58. In spite of the very wide distribution here, when we look at aggregating, say, 10,000 users through a device, then the standard deviation is less than 0.5% of the mean. But we are concerned about scaling this. We do not have any good statistics, whereas we have good statistics on the number of sessions, we don't have good statistics on the session setup rate. There's a study done by a New Zealand university, a very small study that was looking at connection setup rates, but we hope to try to get some more statistics on that to understand on what the setup rates will be for a CGN device. Anyway, so that's the review for a NAT 4.4 deployment scenario.
Thanks, Chris. So the panel will take any questions that anybody might have. Please do head to the mics if you have any. If you don't, I've got maybe some primers. Go ahead, David.
Dave Meyer. 2 questions. First off, in your introduction, you, it's a long time ago now, so I might not get this right, but you said there were like 3 classes of address: public IPv4, private IPv4, and IPv6.
Yeah.
Why don't you think is IPv6, does that include private IPv6? Number one, question number one. Number 2 is, and I'll go sit down after this. The second question is kind of directed at Elaine, or all of you actually. The sentiment I heard from you, or from most of you, is that CGN is a transition strategy to get us to IPv6. You could flip that over and say, if I have CGN, why do I need IPv6?
So let me answer mine quickly, because that's a much more interesting topic. So my answer is yes, David. In fact, the slide was, you remembered it correctly, and in fact, there will be private v6. And look, we're already pushing that far enough. But if you take a look at the current architecture proposed for LTE and mobile gateways of the future, NAT 6.6 will be a requirement to handle that particular service. So let's leave that one for the future. But let's get back to the more interesting question. Anything you like, Lisa?
Sorry that I haven't followed very closely about the NAT 6.6 thing, but I think there's a fundamental question, that is whether private IPv6 address is still globally unique. If so, and that's entirely changed the problem.
Just to follow up on that, the NAT 66 work's all about the fact that, some people out there do believe that NAT is a security device and they want NAT.
Yeah, but NAT is one thing. But if you retain the uniqueness of IPv6 address, independent from whether it's observable or not observable outside, it's separate. Uniqueness fundamentally relates to operations, to debugging, and a bunch of other important issues.
But the second half is really quite interesting. The second half of Dave's question, which is, can NATs successfully defer the transition to IPv6 such that we never need to do it?
So I would like to make a two-part answer to this question. The first part is fairly simple, and the second one is more controversial. Simple one is, as I said earlier, 1 byte that goes over v6 is 1 byte that does not go over NAT, meaning that this NAT infrastructure is going to be expensive as a CapEx and expensive as an OpEx. If we can avoid it or put a cap on it, we will be in a better position. So look at v6 as a way to reduce your NAT cost. Second part of the answer, that is a somewhat more controversial answer, which is, at a certain level, it doesn't matter. Because what matters is that we provide service to the customer, and if it's a state where we end up and everybody is happy, why not?
I just wanted to add one thing on that. Yes, CGN will delay v6. I mean, certainly for us, we want to do the CGN to provide service continuity for customers, and because of that, we're going to do that first. We weren't ready to do v6 yet. It was going to cost us a ton of money, and this will probably allow us to spread that spend out over a certain amount of time. So from that perspective, you can say that yes, it will delay v6, but it's going to do it for us in an affordable way, and we plan on doing v6. It's not like we're going to use this to avoid never doing v6.
Maybe one of the fundamental differences between our two approaches, the DS Lite approach assumes that you already have a v6 deployment, and we will give you v6 at the same time that we will give you this CGN access. So that's one of the key distinctions that I wanted to make.
Sure. Yeah, a couple of points. One is that, just to amplify on what Alana's now said a couple of times, I don't think there's anybody in this room that has so little to do that they're looking forward to maintaining this kind of device or living with this kind of solution in your network. People are not going to do this because it's fun or because it's cool. They're going to do it because they have to, because they have the use case and the business case to do this instead of running a simpler network. But also, pretty much for the length of my career in this business now, I've been told V6 is coming, there's a new generation of V6, of IP, and new things will be enabled by the new IP technology. To some extent, I still believe that. With V6 available, people will be starting to, and operational experience with it, people will be starting to think of things that they hadn't thought of before, and that weren't possible or weren't easy or weren't cost-effective with a V4 network. However, it would also be very unwise to wait another decade for that, because if that was going to do it alone, we'd have a lot more deployment of V6 today. I think what we need to do is address the problem we actually have, which is V4 address exhaustion, and start by doing what we already do and then expand outward from that.
Okay, so just very quick. I think what I learned from the last big debate about NET is that let's do not do dogma. Okay, be pragmatic and solve the problem. You know, if CGN is the cheapest, easiest way, go for it. I think Alain said already, the killer app of the IPv6 is just the large address space so that you can get back to the old model of have a unique address per box, make your life easier as an operator.
Question in the back.
Yeah, Tom Pusateri. My question is for Elaine. What size subnet are you going to allocate at the home?
You mean V6 subnet?
For V6, yeah.
We have not made a final decision on that.
Okay. Do you have any choices that you're considering?
We understand that home networks are going to be more and more complex by the year, so it's probably going to be much more than just 1/64.
Okay, thanks.
Question in the front.
This is more for the AT&T approach, where basically you mentioned something about bypass, which I take it to mean a better technical way that people who've got address space that needs to be netted don't follow a straight path out to the internet. But the question comes down to the point that your scheme will work with all kinds of legacy gear like NAT typically does now. So how are you going to roll this out? Are you going to say, okay, new users get NAT, but old users enjoy their IPv4 globally? Or are you going to take it away from everybody? And if you do, what are you going to do with all that? Wow, we've got a lot of global IPv4 now. We can do all kinds of things with it. And the second question to that is, if you do that, is 10/8 enough?
Those are all good points. Currently, we're not looking to take it away, a public address from a subscriber that already has it. There are people elsewhere in the company who think that CGN would be a great way to gold mine a public space and reuse it somewhere else.
I made that comment a day or so ago.
And well, I'm thinking inside our company, there's people who've suggested that we could use it as a way of mining that. I don't know. We have no plans right now that I know of to do that. And then, what was the other part of your question?
Is 10/8 enough?
Oh, is 10/8 enough? Well, I'm assuming based on how we distribute our DHCP pools and say the fill rate on those pools that we could maybe get 8 million customers out of that. That may not be enough, but I would hope by then that we would no longer need a router in our backbone, in which case we could replicate the address spaces across our metro. I would like to see, I know that several carriers have proposed the set-aside reserved address space for ISP use that's been shot down several times.
I would like to comment on that. The question is, if 10/8 is not big enough, what is big enough? And some people will say, okay, let's just add another one like a net 11. But I could say, well, maybe enough for some people, but not for some others. And the actual answer is, we have 32 something /8 left. Let's take them all.
Well, the reason I said is 10/8 enough is mostly because AT&T is planning to route it over their backbone, so it's got to be unique within their backbone.
Right. So we hope to eliminate that eventually for when the RGs are V6 capable and the management system supports V6. We can eliminate that requirement. When the CVoIP, when we can move that to V6, then we should be able to remove it from the backbone.
Or maybe you could migrate to DS Lite at that point.
Yari?
Jari Arko Eriksson, a couple of comments. First, Dave, you brought up NAT66 and also the mobile gateways. And as someone working for a mobile network manufacturer, I'm not sure I actually agree with you. I don't see a need for that in that particular context, and perhaps even more generally, I don't see a lot of need for NAT66. So I think the real tools that we have at our disposal and that what most people are talking about is regular DualStack, NAT4.4, DualStack Lite, and address family translation at NAT6.4. And my other comment was a response to Lisa. You brought up this work in Behave and the many different forms of NATs. And you were criticizing the fact that there's different types of NATs, which should just have one. And I think that's a fair criticism, but on the other hand, I think the work in Behave is really a set of components that can be used in a different number of situations or scenarios. And I think you were counting the scenarios rather than the actual tools. And it's a good thing that we don't need all the tools in all cases. So there's some simple situations where we can do just pure packet translation between V6 and V4, and we don't need the DNS stuff. And that form of translation doesn't break DNS, doesn't break anything. So it's good for that application. Some of the other forms, they need the DNS parts too. So that's why it looks like there's many different approaches, but it's really a small number of components used together.
As I said, I didn't really follow very closely, but at the high level, I got one impression that people try to optimize for different scenarios.
And that part I fully agree with. So this is really a temporary measure. We should not make it too good. That I fully agree with. But it's not only about optimizing it. They're just avoiding breakage for some types of applications. And I think that's a good thing. And they're not working on 6 different solutions. They're really working on packet translation, DNS parts, and a couple of other things in terms of the address space. And those together can be used to implement those 6 different scenarios.
Last question, please.
Tom Vest, speaking for myself. I think I recall one of Suzanne's slides, she enumerated the list of stakeholders that might or might not need V6. And in light of the doubts that were raised by Dave's question and perhaps by Chris's kind of candid response just recently, I want to point out the fact that, Suzanne, you didn't mention one group who really need it, and that's the people that are not in this room now. Is basically all the new entrants, the kind that the industry has always accommodated over the last decade and a half. They're based on RIR initial allocation stats. They're about somewhere between 1 and 3 of those that appears at some RIR's doorstep every single day of every year. And if we're talking about a world in which there will be, where V6 will never happen, we're talking about a world in which every single day all those people are going to walk away and they'll, basically empty-handed, and there'll be no obvious path to enter this industry in any capacity except for perhaps by securing permission from one of the incumbents to enter. Now, there's a word for that kind of arrangement, which is not a very nice word, and it's not the kind of word that it's amenable to this form of self-governance either. It's a cartel. So, I guess, Chris, I want to go back to the thing you suggested, that some people in your particular company have considered the possibility of mining the address scarcity as a new commercial business opportunity. Can any of you all suggest what the odds are of that becoming an important business consideration or something that influences your deployment plans over time? And or can you suggest any reasons to think that that won't become a serious consideration in the years to come?
I didn't mean to imply that the suggestions I've heard were for commercial opportunities, was only for internal use. I have no idea if there's going to be a market developed where people are selling IP addresses to each other. I assume it will happen, but we need them so badly I couldn't see us selling them to anybody else.
I think I could make a similar comment. The number of addresses that we will need is so high that whatever we can reclaim from our own network will be used immediately, and we will reclaim in order to reuse it in our part of our network. There is no plan that I know of to sell anything.
Well, for me, you already saw my earlier talk somewhere else, that I just don't see anybody depends on the marketing to get enough addresses. Impossible.
I'm not a network operator, so I have sort of a slightly different perspective on it. I understand the concern you're raising, and I agree it's a concern. But I do think, first of all, it's not clear to me that being realistic about things like what Alon just said is making that problem worse. And I will say specifically, I did not say I was envisioning a world where V6 doesn't happen. I am envisioning a world where V6 happens slightly differently than we were originally told it would. And I'll go back to the highly optimistic point I made before, which is that the more flexibility we have in different ways of making V4 and V6 work together, that by side effect is giving us more flexibility about how older technologies and incumbent players will work together, or at least will have the option under the appropriate conditions to work together, moving technology and the business and the ecosystem forward. I think that what we're doing here that does help potentially with the situation you're concerned about is giving people more options, more flexibility, and in non-proprietary, open standards and open source ways.
Thanks, Tom. So David, we're just about out of time, but one last question for the panel, if we could just go down the row, which is, given this conversation and your current plans and understanding, do you envision translators, whether they're NAT 4.4, 6.4, NAT foo bar, back to bar foo, to become a permanent fixture in the internet and in your networks in particular? Why don't we just go this way, Suzanne?
I hope not. Can't really foresee, though. It's about what people find useful in terms of their use cases and what they can afford to provide.
Two answers. One is that money drives. Okay, whatever is easiest way, cheapest way, that's the way they're going to win. So my prediction is that if the translation costs more money in management and other things, they're going to go away for the big part of internet. So my second answer is that the internet is so large, so anything is going to stay forever at some corners.
It's a difficult question to answer. Oh, sorry. It's a difficult question to answer how long those NAT are going to stay in the network. Well, the first thing, they are not in our network right now, so we will have to first introduce them before they go away. I think that as long as there is some significant part of the internet that relies on V4, being on the content being hosted on V4 or being on the devices accessing the content depending on V4, we will have to maintain this bridge. But once again, the more we will move to V6, the less this bridge will have to be growing and growing and growing. So we can expect that we have maybe a 2-lane bridge and not a 17-lane bridge.
Same answer. I can't anticipate when the V4 internet would go away or we cut off our users' access to content that's uniquely there, and I expect it to be there for a very long time for some content.
Fair enough, Chris. So thank you all very much, and thanks, panelists. And